Greetings and welcome back to the CYSA Plus course. I'm Dr. Brandon Brown, and this installment will be on Domain 1 Security Operations and Chapter 2 on System and Network Architecture. So this should be somewhat of a review. Hopefully, by this stage in your career, you would have had a fundamental networking course and a fundamental systems course, and you will have an understanding of networking concepts. So a lot of it might be reviewed, but we're going to get into some specific topics as they pertain to security operations. And the first one's going to be log ingestion. So the key things here are going to be how logs are cataloged, how they are saved, how they are captured, and we use what we call logging levels for that. So this is the typical logging levels that you see in a syslog environment. Cisco follows these. So as a network engineer, I would set up syslogging and then dump logs to a central syslog server, and then they would be categorized by their severity level, from emergencies, which seldom happened, which is good, all the way down to debugging levels, which were primarily used for diagnosing problems and fixing misconfigurations. It is very important that you have network time protocol, or NTP, set up on your system throughout your entire environment so that you can synchronize logs with activity. Now let's cover some OS concepts. So system hardening is going to be around how do we make the operating system, the applications, more secure. But we're going to focus primarily on the operating system itself, updating and patching the system, removing unnecessary software. So I'm sure many of you, if you've bought a brand spanking new laptop, desktop, it doesn't matter what the operating system is. It could be a MacBook, Wintel system. When you do the install of it, or if you buy it out of a third party, say like a Best Buy or off the internet, it's going to be shipped and it's going to have all of this, well, for lack of a better term, junk on it. So all of what we call bloatware. So a lot of times you have to remove that. You're going to restrict logging administrative access. So if logging is set up, you're going to make sure that only the administrator can adjust any of the configuration. Enable logging and using the appropriate monitoring settings, using capabilities like disk encryption and secure boot. So secure boot is basically when you ensure that if something is installed, it is required that an administrator give a password in order to validate its installation. Disk encryption is good. So if you have a laptop and it gets stolen and it doesn't have a password on it, if someone tries to just yank the disk out and put it into another system, it will be encrypted and unreadable. So the Windows registry is also an area of great concern. So Windows is organized in a registry system, and is basically a database for all the different types of settings that control the system. So major root keys here, and this is at the very highest level of what we call the tree. H key class is H key local machine, which is probably the most common, and then followed very closely by H key current user, and H key current config. File structure and configuration files. So within a Windows operating system, program data and program files directory are where a lot of the configuration for the registry live. In Linux, the configuration information is commonly stored in what we call /etc or /etc. This directory is going to have configuration information and setup for all the different types of applications that you will find in a Linux operating system. And in Mac OS, that is similar to library and preferences. So getting into some hardware architecture, one of the most common impacts um, is that malicious software can infect and make it to where hardware does not operate correctly. While most computers now run what we call x86 architecture or instructions for the CPU from manufacturers such as AMD and Intel, there are an increasing number of computers that also run the ARM architecture for the CPU that do not implement x86 instruction sets. So you have some compatibility issues here. All right, let's get into infrastructure concepts. Serverless. So serverless is a concept of being able to run infrastructure as code in a cloud environment. So most of this you would find in AWS, Google, Azure, etc. AWS Lambda is a great example of this, but there are other types such as Google's App Engine and Azure Functions. They all function pretty much the same. Um, what is typically referred to as function as a service. So this is where you can build an entire application or server container as software executing as code without an underlying operating system. Virtualization is going to allow you to run multiple systems um, of, say, the same operating system or multiple different types of operating systems within one device. Think of it like a Russian doll, a box within a box. It's that type of a concept. Containers provide application level virtualization. Instead of creating complex virtual machines that require their own operating system, containers run within an operating system itself and are containerized as a package, and they're very easy to secure in this fashion. Okay, so from a network architecture perspective, and this is talking very high level, we're going to talk about on-premise first, and this is a design to focus on infrastructure found on site, hardware, wiring, routers, switches, servers, complete data center. Everything is under one roof, basically. And then we have cloud computing. So the National Institute of Standards and Technology's definition of cloud computing is as such. Cloud computing is a model for enabling ubiquitous, convenient, on-demand network access to a shared pool of configurable computing resources. Think networks, servers, storage, applications, etc. And these can be rapidly provisioned and released with minimal management, effort, or service. So what the big benefit of cloud is elasticity or expandability. You don't have to come up against a hard wall where if you reach the limit of your compute power or your RAM or your disk space on premises, you have to order more. That's a time constraint. It takes time to procure that equipment, um, process it, buy it, get it shipped, get it set up. Whereas with cloud computing, in a few clicks, you could have that expansion done. So different types of cloud service models are software as a service, infrastructure as a service, platform as a service, and function as a service, which we briefly spoke on. So software as a service provides a customer with a couple of applications that are built to maintain and built and maintained by the service provider. And they run in an infrastructure that is either operated or procured by the service provider. So you're running software inside of an environment. So a good example of this might be Salesforce.com. You buy an account there and you use that software. Or if you were maybe using, say, QuickBooks Online, same concept. Infrastructure as a service offers exposed basic infrastructure building blocks that a user may use in order to design or implement their own service offering. So think of Rackspace. Rackspace is a great example of this because they can basically rent you a server or set of servers or an entire environment. Platform as a service is very similar to infrastructure. It's fully managed and configurable to run customer applications. Customers then deploy applications that they either develop themselves or purchase from vendors. So instead of having infrastructure itself, this may be shared infrastructure. You might be sharing the infrastructure with another customer. Cloud deployments. These basically are the different types of methodologies or ways to envision cloud usage. So public cloud provides infrastructure and then makes it accessible to any customer who wishes to take advantage of it. Private cloud is basically the opposite. You have it operated all the infrastructure by yourself or by your organization. Community cloud is run in a multi-tenant environment, but the tenants are limited to members of their specific designed community. So they're very localized. Public cloud, think AWS, Google, Azure. Private cloud, think of your own data center where you have your own infrastructure. It might be somewhat managed by a third-party entity. Community cloud might be a cloud that is just for a specific industry, a specific customer base, a specific community. And a hybrid is a catch-all. This could be a combination of any two of those three, or all three for that matter. So here's a good example of a community cloud environment. So this is a trust company where they would probably have a digital library, and then you could subscribe to that library. Other people in the community could subscribe to it and use its assets. Of a hybrid, so here's a server rack, and could be in a data center. The data center could be managed by a third party, right? And anything can be running on these systems. So let's talk a little bit about operating in the cloud. All right, so one of the prime tenets of cloud is the shared responsibility model, and all of the major cloud providers, AWS, Azure, Google, they follow this model. So it can then be split up into infrastructure, platform, or software as a service. And you can have things basically cut up into customer responsibilities and provider responsibilities, and then shared responsibilities as well. So software as a service is one where the vendor provides almost all the services, but the data and the security of the data falls on to both. Platform as a service, typically the data is the customers, the application could be the customers, it could also be the vendors. The operating system, hardware, and data center are all the vendors' responsibilities. And in infrastructure as a service, which is what you see primarily in AWS and Azure, the data, application, and operating system are the customer's responsibilities. The hardware, the data center, the operation of the data center falls on the provider. So in infrastructure as code, we see an increasing reusability of code. So a lot of code gets used over and over and over. We stand up a lamp stack basically the same way, regardless of Linux distribution. That's a great example. Increasing the speed of your infrastructure creation and reducing the likelihood of configuration errors. So this is where you have a lot of repetition. That's the word I'm looking for. Thank you. And reducing the time spent by setting up the operating system is critical because your system admins can be working on other parts of projects. So let's dive in a little bit of cloud infrastructure and its security. So cloud access security brokers, these are basically third parties that will work with you in line with your cloud deployment. There are two different approaches with this, inline and API-based. API-based can be where you use third-party software for access to other third-party infrastructures. or inline. Inline is what we see primarily in the security side. Think of a virtual firewall that might be you can buy out of the AWS marketplace or rent out of the AWS marketplace from Palo Alto or Cisco or Fortinet or Checkpoint or any one of the numerous vendors that have those types of products. Network segmentation is basically the splitting or separating of networks via logical or physical boundaries. They're used to segregate trust levels or functional levels. Then we get into the concept of zero trust. Zero trust and its environment basically says that nothing is to be trusted, right? Each action requested and allowed must be verified and validated before being allowed to continue. So this concept is set to help resolve issues of questions that arise when it comes to security, especially around the perimeter, the logical, data perimeter. CySA, or Secure Access Service Edge, is a network architecture design that leverages software defined networking, SD-WAN, SD-LAN. Its security functionality, like cloud, is zero trust based. Firewalls are used as a service. And then you have additional tools like anti-malware, IPS, IDS, and the concept is going to focus on making sure that security at the endpoint and network are all in line with one another. Software-defined networking is the concept that it relies on code as its main mechanism to configure hardware and manage the network. So SDN has been around for several years now. It has had a big push to get out there in the greater community so that we make configuration of routers and switches and access points and phone systems, etc., easily done and easily managed. So the next thing we're going to get into is understanding identity. So saying who you are, identifying or being able to identify what your job purposes, what your roles are, etc. So identities are set of claims made about an individual. So a big piece of this is what we call AAA, authentication, authorization, and accounting. You'll also hear the phrase IAM or IAM thrown around a lot. So identity and access management is what IAM stands for. It's basically, the latest revision or upgrade of AAA. So the infrastructure for this basically is driven by policy. And you only allow access to systems, data, network areas, etc., based on the job role or the need to know or the need to use. Single sign-on is a way that we can incorporate authentication mechanisms into an overall environment. Very handy for the end user, kind of hard to set up sometimes for the engineer. So here are just some shared authentication technologies: OpenID, OAuth, Facebook Connect, etc. And the front end of these would be things like Google Authenticator or any other types of MFA tokens or MFA applications. So then we dive into access control models. There are 5: role-based, attribute-based, mandatory, rule-based, and discretionary access controls. So I think we go into each of these here in a little bit more detail. So threats to identity and its access. So what threatens identity? Personal-based identity security, so who you are. Server-based exploits, so this is primarily based in the operating system. Endpoint-based attacks. So these are attacks that are aimed at end systems like phones, PCs, laptops. You see a lot of endpoint-based attacks come through phishing emails, malware, etc. Application and server based attacks. This might be web applications, so things like cross-site scripting, SQL injection, and then roles, rights, and permissions. So this is where identity really comes into play in role rights and permissions. So compromising a user and then being able to escalate privilege is a key part. And here's where we get into the common exploits of identity and authorization. Impersonation, man in the middle, where you inject yourself. Session hijacking, where you basically steal a session. Privilege escalation, which I talked about previously. And then rootkits. Rootkits are although it's the lowest on the totem pole here, is probably the highest in threat level, because if a rootkit can be injected into an operating system, the only way to be 100% accurate about removing that rootkit is to completely wipe the system and reload it. So let's talk a little bit about identity as a security layer. So this is a rather new concept in cyber. So identity and defense in depth. Defense in depth is not new. It's been around forever. So the more layers of defense that you have, the better off your system is. But pushing this to the identity level is a great way to invoke these security mechanisms. Ensure that only valid accounts are created. Make sure that the correct person gets the account. Ensure that provisioning for rights and management are consistent, i.e. making them change their password at first logon. Tracking changes, roles, and group memberships. So if somebody gets added to a different group, we make sure that we validate that. And terminate accounts properly. So if somebody retires from the organization, we ensure that their account is retired as well, deactivated. Okay, authorization and rights, as well as management. So building a rights management security layer relies on these three basic concepts. Building a set of policies that describe what rights are allocated to each user role. Implementing a management system to ensure that these rights are granted to the accounts that need them. And monitoring and reporting to ensure that they're not being abused. So that's the three guiding principles of authorization management, if you will. So all of this is dependent upon multi-factor authentication. So when we have only two factors of authentication, say a username and password, that can be easily, well, not easily, but more easily hacked. We implement a third factor of authentication, location, possession, knowledge, biometric, etc. We really ensure a better authentication mechanism and cut down on potential for breach drastically. So authentication tokens, here we have a good example of Google Authenticator. I'm a user of Google Authenticator. I love it. It's great. I've also used Microsoft Authenticator, RSA keys, etc. They all kind of serve the same purpose of having an additional mechanism for authentication. So getting into federation and single sign-on. So federations for identity and security considerations. This is where we have an identity provider that can be a third-party asset to identifying your identity. So think of Facebook or Google or some other third party that can use federated identity to validate who you are. So you ever get one of those things online and say, hey, log in with Facebook, or hey, log in with LinkedIn. That's basically what we're talking about. All right. This on the back end is run by something called Login Radius. Login Radius is a way that LinkedIn uses its user base in order to have users register to use their accounts for federated services. So the technologies can also leverage things like SAML, OpenID, OpenAuth, ADFS. They reduce your security risks in these different types of fashions, and the common uses for them, a lot of API, enterprise authentication, authorization, or both. So SAML, which is typically used in email. This shows kind of a general methodology for checking identity. And then we go into OAuth as well. So you can see they're kind of similar to one another. There's a lot of back and forth for token checking, identity checking. And privilege account management, or PAM. This is the concept where we describe a set of technologies and practices that are used in order to manage and secure privileged accounts. PAM relies on the principle of least privilege. That principle of least privilege means that you only give the level of authorization that is needed and no more. So this helps address a lot of issues, including over provisioning or providing over privilege, lifecycle management, prevention of privilege creep. So when somebody gets promoted, they may need more privileges, but they may only be in a role for a certain amount of time. They may be an interim or in an acting role, and they need that privilege. But how do we make sure or ensure that we pull it back? Passwordless. I know this sounds like a really crazy concept. It allows users to log in without a password. Wait, what? In most implementations, this means that the user is going to enter a username, user ID, and then a USB token, authentication application, or other device. Unlike multi-factor authentication, though, passwordless authentication processes typically rely on single factor that is designed to be more secure. So a much more stronger password, cookies that expire after so often, and then you have to redo your password, etc. And last but not least, cloud access security brokers. These are tools and policy enforcement points by third parties that can exist either locally or in the cloud. And they enforce security policies as the cloud resources and services are used. These brokers can help with data security, anti-malware, functionality, service usage, and access visibility, as well as helping you to define risk management within your system. Okay, so that's it. That's all for chapter 2. So thank you. Thank you very much for joining me today. I'm Dr. Brandon Brown, and we will see you next time.